Okay, so this video is just a review of different ways of solving linear equations. So the first method of solving linear equations is by graphing. The steps are outlined here, so you can pause the video if you need to review these steps. So the first thing we'll do is check that the equation is in y-intercept form, that is y equals mx plus b form. Once we have it in that form, then we will look to see if the slopes of the two lines are different. If the slopes are different, then we'll be able to graph these and know that there will be exactly one intersection point. If the two slopes are the same, then you have parallel lines that don't intersect. Or if the slopes are the same and the x-intercept or the y-intercepts are the same, then you have two lines that are essentially the same equation, so they have infinite intercepts. So let's go down to an example. Here we see equation 1 and 2 are already in y equals form. I'm just going to rewrite the second one as negative x plus 9. So now it's in y equals mx plus b form. We'll graph each of the equations. So equation 1 will start at y equals 1, and the slope is 3. We can write that as 3 over 1, which means we go 3 up and 1 to the right. So 1, 2, 3 up, 1 to the right. And we can 2, 3, 1 to the right. We can plot a bunch of points, and that's because it's positive. If it was negative, we would have to go 3 down, 1 to the right. But since it's positive, it's 3 up, 1 to the right. If we wanted to go in the opposite direction, and instead of 3 up, 1 to the right, we can go from our intercept point, 3 down, 1 to the left. And we can plot as many points as we need to get this line. So I'll use a different color for the other line. We'll start at the intercept of 9. And from 9, the slope is negative 1, which could be written as negative 1 over 1. So that means we go 1 down, 1 to the right, 1 down, 1 to the right. And we see we've hit our intersection point, which is right here. And that's at x equals 2, y equals 7. That's our solution. We can check this solution. If we plug this point into both equations, then both equations should be true. So if I look at equation 1, if I plug in 7 for y, and then 3 times 2 for x plus 1, well, is 7 equal to 3 times 2 plus 1? Yes, that's true. So equation 1 is satisfied. Let's look at equation 2. If I plug in that 2, 7, that means I'm replacing y with 7, and 9 minus x is 2. So is 9 minus 2 the same as 7? Yes, it is. That point satisfies both equations in our system, so it is a solution. And by plugging it in, we have verified it as a solution. So here's a second example. And in this example, we need to first rewrite the equations in y equals mx plus b form. So 3x minus 16 equals 2y. Divide everything by 2. We have 3 halves x minus 8 equals y. And then I just flip it using the symmetry property. So this is equation 1 written in y equals mx plus b form. I'll start at negative 8. And my slope is 3 over 2, so I'll go 3 up, 1, 2, 3 up, 2 to the right. I'll keep doing that, 1, 2, 3 up, 2 to the right. And we see the line comes through here. And equation number 2, I'll divide everything by 4. That gives me y equals 10 minus 3/4 x. If we want it in y equals mx plus b form, I'll just use commutative property to rearrange the terms. And now I see I start at 10 because that's the y-intercept. And because it's negative 3/4, I'll go 3 down, 4 to the right. 1, 2, 3 down, 1, 2, 3, 4 to the right. 1, 2, 3 down, 1, 2, 3, 4 to the right. Here's our intersection point, and that occurs at the point 8, 4. I'll leave it for you to plug 8 in for x and 4 in for y. And when you do that, you should get true statements for both. And that is our examples with the graphing method. Next is solving systems of equations using the substitution method. So here we see that step 1 says solve for one variable in at least one of the equations if necessary. Then substitute the resulting expression into the other equation. And once we have the substitution step done, we solve that equation because it becomes an equation with only one variable. Then we have to plug in our solution back into the equation to find the other variable, and we check our solution in the other equation. That sounds like a lot. Let's see it worked out. So the equation is already solved for y. Because it's already solved for y, it's already solved for one variable. Now anywhere I see a y, I can plug in 2x. So I take the 2x and I plug it in, and it becomes 2x equals x plus 5. So this is the substitution step, and the substitution step gives us an equation with only one variable. There's only x variables now. So all we have to do is solve for x. We'll subtract x from both sides. That gives us x equals 5. But we need to know what y is also. So if we plug 5 in for x, we get y equals 10. Well, let's plug 5 in for x in the other equation, and we get y equals 10 again. And we say, well, they match. Since they match, that means that it satisfies both equations and gives us matching answers. So the solution to this system is 5, 10. X equals 5, y equals 10. So here's a second example, and if it wasn't solved for a variable, we would go ahead and do that, but this is already solved for y. That means anywhere we see y, we can plug in x minus 4 into that variable. So equation 1 becomes 2x plus, but now we're going to replace y with x minus 4 equals 5. Again, the substitution step gives us an equation with one variable. If it's an equation with one variable, we know how to solve those. Those are easy. So now combine like terms. So we're going to combine the x's. 2x and x gives us 3x. Minus 4 equals 5. Add 4 to both sides. And we have 3x is equal to 9. And divide both sides by 3. And we have x equals 3. Well, now we take that back into the original equations, and we say if I plug in 3 for x here, I get 6 plus y equals 5. Subtract 6 from both sides, we get y equals negative 1. Well, let's plug that x into this equation and see if we get a matching y. So when we plug 3 in for x, 3 minus 4 is negative 1, so y equals negative 1. They match. We can say the solution is 3 comma negative 1. 3 is our x, negative 1 is our y. That is the solution to our system. So we've seen 2 examples now with the substitution method. So our last method is solving linear systems using the elimination method. So in the elimination method, we're asked to write the system so that like terms are aligned. That means x's over x's, y's over y's, equal signs over equal signs, and constants over constants. Then we choose a variable we want to eliminate. We modify the equations so that it does eliminate. That means get matching coefficients and opposite signs so that they'll cancel. And we'll solve for one variable, plug back in to get the other, kind of like we did with the substitution method. Again, that's the explanation. Let's see it in action. So we see that this is lined up already. We have x's over x's in the first column, y's over y's in the second. The equal signs are over the equal signs, and the constants are over the constants. It's already aligned. So if I take this second equation and I add it to the top equation, we see that x plus 5x is 6x. And then we see negative 2y plus a positive 2y cancels. So that's why it's called elimination method. The y's will cancel. The equal signs come down, and then we have negative 19 plus a positive 1. That gives us negative 18. If we divide both sides by 6, we get x equals negative 3. Well, now that we have x, we plug it back into one of our equations to get y, and then we plug it into the other equation to see that the y's match. So if we plug negative 3 into this x, so for equation number 1, we get negative 3 minus 2y equals negative 19. Add 3 to both sides. So the 3's cancel, and we're left with negative 2y equals negative 16. Divide both sides by negative 2. We get that y is equal to 8. Well, that was from equation 1. Let's see that we get the same y from equation 2 when we plug in negative 3 for x. So we get 5 times negative 3 plus 2y equals 1. And this is negative 15. Plus 2y equals 1. Add 15 to both sides, and we have 2y equals 16. Divide by 2, we get y equals 8, and the y's match. So then we can say our solution is negative 3, 8, where x is negative 3, y is 8. And our final example, using elimination, we see that if I were to add the top and the bottom equation, the x's would not cancel and the y's would not cancel. So in order to get them to cancel, if I multiply the entire equation by 2, that means it would be negative 2x plus 6y equals negative 24. We're doing that because negative 2x, if I bring this equation down and write it, negative 2x and positive 2x will cancel when I add them together. So now when we add, we see that these terms cancel. That's the purpose of elimination method, to get one of the variables to cancel out. 6y plus y is 7y, and negative 24 plus 3 is negative 21. Divide by 7, and we get y is negative 3. Now we go back in and we substitute in for y and find x. So for equation number 1, we have 2x plus y is negative 3 equals 3. We have 2x equals, add 3 to both sides, and we get 6. So x is positive 3. Well, let's see if we get the same x from equation 2. So equation number 2, we have negative x plus 3 times y, but y is negative 3, equals negative 12. Negative x, 3 times negative 3 is negative 9, equals negative 12. Add 9 to both sides, and we have negative x equals negative 3. Divide both sides by negative 1, and we have x equals 3. And the solutions we got match. So our solution here is 3, negative 3. So that was a quick review of solving linear systems using graphing, substitution, and elimination. I hope this helps. Send me questions if you have them.